Namaskar. In last lecture, we discussed different type of press tool and components, also different miscellaneous dies. We discussed simple dies, compound dies, combination dies. Today we will discuss progressive die. Progressive die, which is also known as cut and carry die. It is a multi-station die that performs several operations in successions in a single stroke of the press ram. The various operations may be all cutting operations or a combination of cutting and forming operations. The first step in the design of the die is to the development of the blank. For this, the direction of metal grain is kept in mind. Normally, the grain of coiled strip is parallel to its length. To eliminate any tendency to fracture, the forming operations are usually performed perpendicular to the grain. Thus, while making a scale layout of the developed blank, the bent line is kept perpendicular to the strip. So this is very important thing we have to consider while considering or designing or preparation of the blank or strip. The next step is to plot the parabolic design of the scrap strip. In a progressive die, the individual operations, which are normally relatively simple, are combined in several stations. So due to this, it is usually difficult to evolve the most practical and economical strip design for optimum operations of the die. However, when establishing the sequence of operations for progressive dies, some guidelines should be considered. While evolving the strip design, the positioning and proper location of the stock in each station is of prime importance. For this, pilots are incorporated in the die. Advantage should be taken of any required hole in the workpiece for piloting. So this method is known as direct piloting. Thus, the piercing operation must be placed first in the sequence. However, sometimes when direct piloting is not ideal or satisfactory, the special piloting holes can be placed in the scrap part of the strip. So this is also called as indirect piloting. So what are advantages? Advantages of indirect piloting are greater freedom of size and location and not affected by workpiece change. However, the material width and the lead may increase. So care must be taken to avoid having pierced holes tool close to the bend. So distribute the pierced areas over several stations if they are close together and are close to the edge of the die. We require to check if the blank area can be divided into simple shapes so that the commercially available punches or the simple counters may be used. A blank area will be partially cut at one station and remaining area will be cut in later station. Now we'll see one simple animation which shows how the progressively the cut and carry die takes place. So let us see one video.
Show the working principles of progressive dies. The progressive die shown in this video is used to produce washers, a round metal piece with a round hole in the middle. The progressive die produces the washer with 2 strokes, but each stroke produces 1 washer. This is accomplished as follows. When a new strip is loaded to a press, the first stroke punches the inner hole of the washer. After the stroke, the strip hope you enjoyed this video.
So this is about the progressive die. So it is also known as cut and carry die. And it is a multi-station die that performs several operations in succession in single stroke of press ram. So in this operation we observe that in first the punching is there, or piercing is there, and next the blanking is there. So this example is for the production of the washers having some internal hole. While evolving the strip design, some considerations we need to consider, that positioning and proper location is important. So in this method, even though it seems simple, the accuracy and precision is required. Then only you can carry out the simultaneous operations. So use the ideal stations. So they help the designer to distribute the total load uniformly over the complete length of the die. They also strengthen the die blocks, stripper plates and punch retainers. Then facilitate strip movement. So this permit later changes in workpiece design by providing some additional operations. So some important things are required. The bending and forming operation must be at least at the last station. Then cutting and forming areas should be located to provide uniform loading of the press slide. While designing strip layout, try to minimum scrap and use a multiple layout if possible. Design the strip so that the scrap and workpiece can be rejected or ejected without interference. So next step is to design the die. So there are several steps. So the second step is to consider some considerations. Now next step is to design the die. The design of various die elements, So die consists of die block, punches, strippers. So it is done on the same line as like a blanking die or piercing die. We discussed in chapter 2. Progressive die is usually heavy in construction. So the counter bores in die block, the tapped holes in the die shoe and rimmed dowel holes in the die shoe must all made with the from 6.3 mm to 9.5 mm deeper than needed to allow for grinding of the die block. If the punch diameter is twice the material thickness, it need not to be guided. If the punch produces, if it is less than 2T, then it requires the jig or guide. If the punch produces the hole 40% deeper than its own diameter, then the shank diameter must be at least twice the punch size. Otherwise the tool may bend. So the punches should be a tap fit in punch plate. For purposes of stability, the flange of the punch should never be smaller in diameter than the length of the punch. Punches should be secured with pins, flats, keys against the rotating in the punch holders. So there are some dimensions. So there are different, die area and thickness, and accordingly the minimum guide post diameter is decided. So using some data handbook, you can refer the data to design such dies. The shed height is established by the length of the guide post, and it must be at least 12.5 mm shorter than the shed height in order to allow for the reduced shorter height due to the resharpening. So we discussed different types of dies and also miscellaneous dies. So material used in such dies we will discuss today. What are different materials are required? So tool materials are chosen mostly on the basis of expected life of the production run. What is required? So major is expected life of the production run. Efficiency, strength and dimensional stability of the working part of the tool depends on material for each component and its heat treatment also. Not only single material, but once you select material, which heat treatment is used. The tool steel used for punches and dies should possess some properties. Some properties are required which is used as a punch and die. So high strength is required, high hardness is required, adequate wear resistance is required, high toughness is required, good hardenability. It shows little sensitivity to overheating, good machinability is required, good grindability is required. So blanking tools are subjected to severe wear and are made from the various cold working dies, steels. Bending and drawing dies are made with similar materials. Although cast iron and even hard zinc alloys and plastics are suitable for short production runs or for softer workpiece material. So some of the important materials we require to consider while designing. So blanking for aluminum, magnesium and copper alloys. So zinc alloys, water hardening steel, oil hardened steel, air hardened steel and cold die working steel is required. Hardness should be very strong, 57 to 62 HRC. So for steel and nickel, so molybdenum HSS, high speed steel is required. Its hardness should be 60 to 66. For deep drawing process, already we discussed, it comes under forming process, deep drawing process. So these processes are carried out on different materials. If non-ferrous material, that is aluminum, magnesium and copper alloys, so water hardening steel is used, oil hardening steel can be used, air hardening steel can be used and cold working die steel also can be used. And for steels and nickel alloy which requires more strength, for such material water hardening steel and molybdenum HSS hardness varies from 60 to 66 HRC is used. For press forming, for aluminum, magnesium, copper, epoxy metal powder, zinc alloys, mild steels, cast irons, oil hardened steels, air hardened steels, cold working die steels are used. And for steels and nickel alloy, epoxy metal powders are used. So die material mentioned are for light duty short runs. Other basic die materials are aluminum bronzes. These have often used for draw ring and other forming tool, especially those intended for working stainless steel. They possess fair machinability, high dimensional stability and high anti-galling properties, high compression strength, good retention of high polish and no need for heat treatment. So if for medium size draw dies, regular counters, okay, the semi steels are used sometimes. It is a term often applied for cast iron. Semi steels are alloy with 10% silicon, 1% nickel, 2% chromium and 3% magnesium. So it is the most commonly used for strippers, blank holders and secondary structural members of die. So flexible, short run and alternative materials are used. So these alternative materials are ceramics, kirksites, plastics and rubbers. So ceramics is a special low melting point alloy of bismuth, lead, tin and antimony with hard setting and expandable properties, designed specifically for die application. It is widely used for repair of die and for the sitting and holding of punches and die sections, especially long slender members in intricate dies where precision machining would normally be time consuming and costly. The material is also used as a form block or die block member is short run forming. Then Kirksite, a cast zinc based alloy with aluminum, copper, magnesium is extensively used in aircraft industries and to some extent in automotive industries for large forming, drawing, stretch forming. It is most applicable on experimental short production run. Kirksite dies are quickly made, being cast closely to shape and size required, and are used without heat treating and are easily finished. Then sometimes plastics are used. The cast phenolics, cast or laminated epoxy, and glass enforced polyesters. They are providing an exceptional benefit to the aircraft, automotive, appliances, and other industries for certain types of work. They are used principally for large forming and drawing dies, where their fast fabricating time, low cost, and lightweight are some advantages. So they are easily repairable, they can be easily modified. So plastics are not necessarily limited to short run or experimental dies, but they are also used practically in some applications. So rubbers are mostly used in forming dies. Forming dies, rubbers are also used. Some sintered carbide dies are also used. So carbide dies are strong, having high strength. They are longer life of tools for different place working operations can be achieved by using inserts made from tungsten and cobalt carbides. So carbide tools have found widest application in large mass production or lot and mass production, where the conventional steel dies and punches do not prove stable enough, which calls for frequent duplication of dies. The life of carbide blanking dies is 8 to 9 times more than usual. So this effect grows manifold when operating on high strength sheets of stainless steel, electrical and similar steels. The carbide dies are used. So they are 50 times more durable compared to conventional dies. So carbide dies differ somewhat in design from steel dies, which is due to the physical and mechanical property of carbides. The design and manufacture of such dies must ensure high stiffness of the die structure, high wear resistance of guide posts, bushings, stock guides, stops and other die components, securing fastening of carbide inserts and their accurate fitting to the bearing surface. Minimum penetration to the punch into the die ensures by the application of limiting rests. So elimination of effect of inaccurate travel of press slides by using float type shunts and symmetrical arrangement of guide post with respect to counter of cut, increased punch to die clearance. So these are different types of die materials. We discussed different materials. So it depends upon the type of press operation, for blanking, for deep drawing, for press forming. Different dies are used for flexible, for short run, for long life. So ceramics, Kirksite, plastics are used or rubbers are used for durable, for long duration, long life. For heavy metal, for hard metal, sintered carbide tools are used. Okay, and how these dies are manufactured? This die for sheet metal working are manufactured by same process as used for manufacturing of forging dies. In case of forging also, the similar dies are there. So mechanical machining method, that is copying milling or NC milling, then electrodition machining or electrochemical machining or casting. So dies can be manufactured by the method individually, or these processes can be combined to manufacture the die to lower the cost and get higher strength. Then so there are several methods. Now we'll discuss one by one. So for manufacturing of blanking and piercing die, among the mechanical machining process, in addition to to the more common methods milling, turning, grinding processes such as sawing, shaping, planing are also employed. So with electrodischarge machining, besides die sinking, cutting may be also performed using NC wire electrode. Size of workpiece, the desired contour, the die material and required accuracy all influence the choice of machining process. So cutting edges are usually machined conventionally to require tolerances. In case of simple counters such as those with cylindrical opening, more complicated counters are usually machined by conventional electrodischarge machining or wire electrodischarge machining. So this results in significant cost and time saving. For example, with die made of EDM die sinking and cutting using wire electrode has led to improvements in quality because of elimination of distortion and of improved strain. So this is because hardened tools can be machined by EDM. So CAD/CAM techniques minimize the production cost involved in die design, manufacturing, maintenance and modifications of die, especially for the design of progressive dies and dies of complex configuration. So CAD/CAM helps lot much. So additional heat treatment of the die surface such as nitriding, surface coating of tools with layer of iron, so leads to significant reduction in wear of cutting edges. So these are new technologies used for manufacturing of blanking and piercing dies. For manufacturing of dies for sheet metal working, that is deep drawing, so some other processes are required, a similar process are required. In a single or double convex or concave working surface of sheet metal, dies are largely machined by copy milling or EDM. In case of medium and large size dies, the die block is generally cast with 10 to 25 mm machining allowance. The choice of one or two process combinations is based primarily on the complexity of master models and electrodes and on the amount of hand finish required in the form of spot grinding, lapping, polishing and so on. In conventional manufacturing, using copy milling, individual dies are first rough and finish milled following the master pattern. After initial grinding to smooth down the milling edges, the surface is spot ground using the bluing models, smoothed and then polished. With the complex die shape, the finished made die may be used as a bluing aid in finish grinding the lower die. The desired gap width required for the sheet metal is checked with the aid of lead or aluminum wire. So EDM is best suited for finishing pre-machined dies to a high standard of accuracy and surface finish. The machining allowances may vary between 0.2 to 0.3 mm. The overall machining time may be reduced by 20 to 50% and depending on the die geometry, the time required for manual finishing by 40 to 90%. The die blocks made by casting are first counter milled and then the remaining working surfaces are rough machined using copy milling. About 0.2 to 3 mm is left on the die surface and machined by EDM to tolerances of 0.1 to 0.3. A surface finish of 1 to 3 mm. The final manual finishing consists of grinding the projection left opposite the electrolyte supply channels as well as the edges formed between neighboring element in the case of multiple electrodes. This is the best done by using the bluing model. In addition, minor shape correction may be made where the electrodes are worn out and the drawing radii may be smoothed out and polished. Now the large working. In large working, the die of large working surface areas and gradually changing curvatures such as dies for automobile body parts, that is doors, roof panels, etc., are mainly machined by copy or NC milling and require little subsequent hand finishing. With large body panels, perfect streamlining is essential. This requires special precision machining. Heavily ribbed and ridged deep drawing design or die may be machined advantageously using EDM, electro discharge machining. In general, working surface greater than 1 square meter are considered large dies, while the small dies working area 10⁻³ to 10⁻⁴ mm square. So if you want to machine a punch, okay, so some steps are involved. So first, cutting of blank, then rough machining, then rough grinding, then hardening, then finish grinding the profile, finishing the profile, and then sharpening the cutting face. So these are some steps of machining of punches. The straight punches for blank, round contours and piercing round holes are easy to manufacture. They are turned on lathe, hardened, ground on circular or universal grinders, Then their working surface is finished by polishing and cutting face is sharpened. The shape punches are far more difficult to make. Some steps are involved in their manufacturing. The contour of punch is first machined on metal cutting machines, keeping an allowance for further machining. Then an impression of contour is made by the hardened and finished dies. Next, the punch is filed off according to the contour of impression with due account for the required die punch clearance. Lastly, the punch is hardened and its working part is finished. Okay, this is about the particular dies and machining of dies. Then, how to increase the press tool service life. The life of press tool may mean any of the following, that is number of stamping made between sharpening and repair, between the two sharpenings, between the two repairs, or the total number of stamping made before the tool is completely worn out. The life of press tool can be increased by case hardening, chrome plating, and cemented carbide inserts. But cemented carbide inserts increases the life of press tool dozens of times. So hard facing of tool aims at increasing the wear resistance of new, mostly large size press tools, and at reconditioning worn tool. Hard facing is done by means of oxyacetylene flame. It is done with special electrode and hard alloys. So electrodes 6 to 7 mm in diameter and 400 to 500 mm long are used. The material of electrodes is satellite for blanking and cut off dies and chromite for bending and draw dies. So the hard face press tool is placed with warm sand to allow it to cool slowly. The face. So here sand is used for cooling slowly. The hard face parts are annealed at a temperature of 800 to 900 degrees centigrade for 2 to 4 hours and subsequently tempered in at a temperature 450 to 600 degrees centigrade for 1 hour. Okay, so this is about the materials used in dies and how the tool life or press tool life is increased. And how the machining of the punches and dies are takes place, we discussed. So in next session we'll see the selection of press. So for selection of press, you must know what are different types of press, what are different types of tools, what are different types of operation. Then only you can able to select press. So today we discussed progressive die. Also we discussed different materials required used in sheet metal working dies. So in that we discussed the blanking die material, deep drawing die material, press forming die material, then flexible short run alternative materials. Then for the hard centered carbide dies, we discussed. Then die manufacturing, we discussed different methods, that manufacturing of blanking and piercing die we discussed. Also manufacturing of die for sheet metal working, that is for deep drawing, we discussed. Then how punches are machined, and how to increase the press tool service life, we discussed. Okay, all these points we covered today. If you have any doubt, you can ask your query or submit your query in comment box. Also in next lecture, if we engage during the doubt clarification session, you can ask me your doubts. In next lecture, we'll discuss the selection of different presses for different application we'll cover. Okay, till then, thank you very much.